All right, Colts, we're going to do 2.3 notes for deductive reasoning. So remember in 2.1 we did inductive reasoning, and inductive reasoning is when we talked about patterns. We were kind of making assumptions based off the things that we saw. We had conjectures. If we could disprove them with one example, a counterexample, then it proved to be false. So that was inductive reasoning. So reasoning that uses information from different examples, so they're specific or that they are an observed pattern. When we talk here about deductive reasoning, okay, it's going to be the process using facts, rules, and definitions. And another way we could say that is that I want evidence. I want evidence showing me that this will prove this thing to be true. So maybe you think of like criminal justice when it's talking about fingerprints, okay? When they're trying to solve a case, they're going to use evidence to eliminate suspects and things like that, or identify someone for the crime. So in this case, we're going to use facts, rules, and definitions. So if you remember our definitions, okay, is this one where we have the 13 definitions is the first one. We have another one. This is one we're mainly going to be working with, starting off when we do our proofs. But those are going to be some of those definitions we're talking about here. Okay, the law of detachment is going to be a form of deductive reasoning that draws conclusions from a true conditional. Okay, from a true conditional, our true conditional being P then Q. So that means our statement, starting off P, is true. So if P then Q is a true statement, and P is true, then we can conclude that Q is true. So if I know P then Q is true and P is true, I can conclude that Q is true. So an example with words is going to be, if a car is out of gas, then it will not start. And if I say Sarah's car is out of gas, I can conclude that Sarah's car will not start based off of that first if-then statement. I'm going to pick a different color highlighter to go through this with you. Okay, so one of our next example. Determine whether each conclusion is valid based on the given information. If not, write invalid and explain your reasoning. So, two angles supplementary to the same angle. This is my P, and then it tells me that they are congruent. That's my Q, okay? It's telling me that that is true. If two angles are supplementary to the same angle, then they are congruent. And it's telling me that angle A and angle C are supplementary to angle B. Okay, so it helps when I have a picture here. If I have angle A and I say angle A is 10 degrees, I can conclude that angle B is 170 degrees because they are supplementary. And therefore, because angle C is also supplementary to angle B, I can say that angle C is also 10 degrees. Because they are both supplementary to angle B, I can conclude that angle A is congruent to angle C. They both end up being 10 degrees in this example. The way that I write it out is I say if two angles are supplementary to the same angle, then they are congruent. The statement angle A and angle C are supplementary to angle B is the hypothesis of the conditional. Therefore, by the law of detachment, okay, we see that the conclusion is true, and we say that this is valid. A good way to see it is if it maps it exactly. My blue goes with my blue. The first one is vague or general, and the second one is specific using angles A and angle C. And then I look here. My first one is vague. I just say congruent. And then here, second one, I use those specific angles for it. All right, so we're going to go down here to example B. If Helen is going to work, that's my P. Q, then she is wearing pearls. So then it starts off with Helen is wearing pearls, which is my Q. Well, we can conclude that Helen could be wearing pearls for something else. Okay, so this would be an invalid conclusion. Okay, so we cannot use the law of detachment in this case. You want it to match. This one should have started with Helen going to work. Okay, then we could have made a conclusion. But because it did not, okay, it's not going to work. For number 3, we're going to see if a number is divisible by 6, then the number is divisible by 3. So that's my P then Q. So then I start off and I have my blue that matches 18. Is divisible by 6. Okay, and I can conclude that 18 is also divisible by 3. 18 is divisible by 6, that's true. And I can conclude that 18 is also divisible by 3. And from that, I would use the law of detachment. Number 4, if a pet is a rabbit, then it eats carrots. And Jenny's pet eats carrots. Well, again, it doesn't match my P, then Q. I should start with rabbit. Okay, I can conclude that Jenny's pet could be something else. It could be a horse. In our case today, we talked about it could be a donkey. Okay, number 5, I crossed off the Plymouth Rock. If you're not sure about hens or species of hens, I used one. If Micah goes to the beach, she will wear sunscreen. Micah's at the beach, so I can conclude that Micah wears sunscreen. The example underneath, though, it says, if a hen is a Plymouth Rock, which is the species, then it says Berta is a Plymouth Rock hen. So notice how they match. One is vague or general, and one is specific. And then I would say, then her eggs are brown. And then I would say, conclude, Berta's eggs are brown. And I could say that's valid by the law of detachment. All right, jumping down to the law of syllogism. Another way to make a valid conclusion. And this one is when we're going to have two statements. We're going to say if I have P then Q and Q then R, and I know that they're both true, then I can conclude that P then R is a true statement. I want you to notice that there's a Q for both of these, and these Qs are going to be the same thing. This conclusion of a Q is going to be this hypothesis for the second statement. So using our example here, it tells me that both statements are true, and if P, which is if a number is a whole number, then the number is an integer, that's my Q. That's true. Okay, and if a number is an integer, my Q, notice how the greens match, then it is a rational number, okay, which is my pink. That is true. It told me it was true. So it's saying use the law of syllogism. I want to go if P then Q, Q then R, then I could say P then R. So based off of my highlighting, I'm going to do yellow to pink. So I'm going to say if a number is a whole number, then it is a rational number. Using my law of syllogism. So like my green is like the link between the two. Okay, a couple more examples. Using the law of syllogism to draw conclusions. So I wrote the law of syllogism up above to help us. P then Q, Q then R, then P then R. Okay, so if a dog eats superfood, P, he will be happy, Q. And then it says Rover is happy. Notice here, it doesn't have if he will be happy, then something else. It should start with if, happy, and then lead to something else. And it doesn't do that. So because of that, we cannot make a valid conclusion. For number 2, if an angle is a supplementary to an obtuse angle, it's going to be our P. And if our Q is, then it's acute. And notice when I start here, an angle is acute, it matches my Q when it was a conclusion. And then it says then a measure is less than 90 degrees. So I can write P then Q. If P then R. If an angle is supplementary to an obtuse angle, then its measure is less than 90. I'm able to make that conclusion because both of my blues link. Okay, and then jumping down to number 5, if you study for the test, then you will receive a high grade. So my next sentence should have started, if you receive a high grade, then something something, right? Okay, this just says your grade on the test is high. It doesn't follow that law of syllogism. So in this case, we would not be able to make a valid conclusion. And that concludes our 2.3 notes. Okay, doing your 2.3 homework is going to help you to solidify deductive reasoning the best. The best way to do this is just practice, practice, practice.